All right.
Welcome, everybody. Thanks for coming. My name is Brad Topol. I'm an IBM Distinguished Engineer. I'm a Kubernetes contributor, a member of the Kubernetes Conformance Workgroup, and a kube doc maintainer. And I'm going to let Michael introduce himself.
Sure. Hi, my name is Michael Elder. I'm also an IBM Distinguished Engineer. I focus on product development, technical strategy, architecture around our offerings around IBM Cloud Private and Multi-Cloud Manager, which include Kubernetes along with other components.
OK, and today we're going to learn how to leverage Kubernetes to support 12-factor for enterprise apps. So what are we going to be really focused on? This is the excitement. Let's go deploy our apps on the cloud. And why would we want to do this? So cloud has evolved as a strategy for disruption and continuous delivery. So if we look, we all know the great examples that we see. Small little businesses like Uber and Airbnb start small. They're able to scale up quickly on the cloud, and they're able to disrupt complete industries. So a lot of power in this cloud stuff. And with the cloud and enabling microservices and the architectures to scale out quickly, we can roll out new updates at immense speeds. Now, I love to think of good examples of why would a company need to roll out changes very quickly at rapid speeds. And there's one that just happened the other day. So if people are familiar with Uber and how it works, that if there's not a lot of cars available, they do a surge and the prices go up. So I don't know if any of you all saw this. I know Jeff Bork saw it because it was on his Twitter feed. But at Reagan National Airport, the Uber drivers had figured out that several times a day, they all at the same time turn off their app. And what happens? The surge kicks in, the rates go way up, and then they start picking everybody up, and they're making a lot more money. So probably Uber wants to get a fix out there because that's just going to get old real fast. Obviously, in the cloud, data becomes the fuel for business innovation. And when you have lots of services out there, and we have lots of AI-based services, wonderful ways to combine the different services to do a lot of really cool stuff in the enterprise and for businesses. And really, what are we talking about? Ideally, profit or reduced cost. So a lot of good reasons to move to that cloud. So what is 12-factor? 12-factor is a software methodology for building scalable microservice applications. It was originally created by Heroku. It's best practices that are designed to enable applications to be built with portability, resilience, scalability when deployed to the cloud. And so I'm going to go into these in much more detail on the next chart. But the big key things to take away here is the 12-factor makes it easier to run, scale, and deploy applications. It helps keep parity between development and production, and it provides a strict separation between the build, release, and run stages. And so when we like to describe these different 12 factors, it's easiest to break them up into 3 categories of the life cycle: code, deploy, and operate. And so I'm going to give you a taste of each one of these. The factors that deal with code, factor 1 of 12 factors is one code base, tracked and revision control. So what don't you want to do? You don't want to have 5 different versions of your code, different people running and deploying from those 5 different versions. Because you know what? Eventually you're going to have a bad day and bad things are going to happen. So ideally, you want a single code base, and from that single code base is where you're going to be deploying and building and et cetera. We want separate stages for build, release, and run. So strictly separate those stages. I've seen this at many container talks where they make it very, very clear. Listen, you may have your containers out there running. You don't want to go log in and patch that container where it is, right? Because you know what's going to happen? A couple weeks will go by, go out and have friends, maybe go on vacation, and you're going to forget that you did those patches. And when that eventually crashes and it's trying to do a new build, those changes are going to be lost. So it's very important that instead of going out and doing that, that you have a very efficient build, release, run cycle where you're making sure you're putting all the changes back into the build and deploying from there. The next key factor on the code side is parity between development and production. How many people in this room have had to use that wonderful line, hey, it worked on my laptop? Anybody? Yeah, there's a lot of people out there. So, and why does this happen? Well, if the laptop environment is different in certain ways than production, that may creep in and you're going to see it. So anytime we can use techniques to make the development environment look as much like the production environment as we can, huge win to hopefully not have to have that awkward conversation that we all know we've had. So let's move on to the deploys, right? So under the deploys, dependencies. We want to explicitly declare and isolate our dependencies. And more importantly, whatever dependencies and software that your application relies on, we don't want to assume that the right version is there on production. We want to make sure that you're taking whatever exactly you need with you and going in production, so there's no surprises of versions or what have you. Another big 12 factor is configuration and storing the config in an environment. So we don't want to take your configuration information and hard code it into the code. That's Henry Nash's favorite trick. He loves to do that. Thank you. So you don't want to do that. And the reason you don't want to do that is if you can keep that information in the environment and not in the code, that if you need to move the service and move it to another environment, then it's much easier to port the code to a different environment because all your environment information is not, hard-coded in the code. Factor 4 here is backing services. You want to treat your backing services as attached resources. The best example of this is being able to attach and detach databases. So if you have your database and something goes wrong with the database, you should ideally be able to detach that database and attach a new version of the database and not have the world crashing down on you. Factor 6, processes. Obviously, we want to make our application run as stateless processes. It's a big factor in 12 factor. If they can run as stateless processes, it's much easier to scale them up and have a lot of them running. Port binding. Having your application built as services that are exposed as a port enables a lot of reuse. Anytime you get a lot of reuse is another excellent factor of the 12 factors. And we're almost done here. We're going to go to the operates. And these are pretty easy to describe. So we'll go to the operates. Concurrency. We all understand why we want concurrency. When things really pick up and the site starts getting pounded on, we want to be able to quickly scale up, and supporting concurrency is huge. Another factor, factor 9, is disposability. Ideally, if your application crashes, it shouldn't be the end of the world. Right? It shouldn't be the end of the world. Some way that should be able to be restarted and life is good. So we want to have an approach for handling disposability. From a 12-factor perspective on logs, ideally everything should just write to standard out and there'd be some other tool or mechanism that gathers everything up so things don't have to do something special for how the logs are written out. And there should be a way for in factor 12 to handle admin processes. Maybe you need to generate a database schema, some other type of administration. There needs to be a way to do that as well. So these are wonderful best practices for building scalable, robust applications. Heroku demonstrated how well they worked, and a lot of literature has been written about it. And what we're going to demonstrate today, and I'm going to lead the hard part to my friend Michael, because that's what I always do. If y'all know me, that's something I would clearly do. I'm going to leave the hard part to Michael. Michael's going to show you how all these wonderful 12 factors can be mapped to mechanisms and things that are provided by Kubernetes. And he's even going to demo it. So at this point, I'm going to enjoy my easy role talking about the 12 factors, and I'm going to let Michael do the hard part.
All right, thanks, Brad. I appreciate it. So what we wanted to highlight, we think about these three groups. Okay, how do we begin to make these real with Kubernetes? So one of the neat things is that when you look at Kubernetes and you look at how it defines its architecture, it's heavily influenced by these 12 factors. So the way that I think about code base, I can capture all of my content, whether it's Docker images, whether it's the YAML configuration for Kubernetes. This is text-based content that can be easily source controlled and managed and can feed into a build system which can package it up. So we'll see some examples here in a few minutes of how Helm provides a default package manager for Kubernetes and how it brings together different parts of that API layer that's really the API captured as text. So code base and being able to drive everything through a declarative mechanism becomes a critical factor in building containerized applications in Kubernetes. Being able to tie this into a continuous delivery system, so how I build and package the image, the Helm chart, and then promote that built artifact from development all the way through to production. What's really powerful then is because it's simple and consistent to deploy this containerized workload with its standard configuration, this enables me to drive better parity between a development environment and a production environment. So it may become the day that when I say it works well in my laptop, what I'm actually saying is that I took the containerized version of the database, ran it in the correct highly available topology. I took the correct version of my app server, ran it in a correct highly available topology, and it worked there, and that's representing exactly how I'm going to run it in production. And so we talk about parity by reducing the number of differences between a development context and a production context. It really helps eliminate sort of errors of absence, sort of the I forgot that it was this variable in production, or I forgot that it was configured with TLS security in production, but it worked fine in development and the issue was with the certificate. Those nuances, those deltas, those differences get pushed to zero, and so you get a more consistent way of promoting that content from one stage to the next. This becomes very powerful when we think about the deploy factors. So Kubernetes introduces a few key concerns. Each of these objects that you see out to the side in a box is the Kubernetes object. So how many of you are writing Kubernetes applications today on a regular basis? How many of you are still in that learning mode? How many of you are writing and learning at the same time? Hopefully everybody, right? So when you look at Kubernetes, this is what we mean when we say that it's heavily influenced by 12-factor. When I think about 12-factor and I think about how I manage configuration, Kubernetes gives us constructs for the config map and the secret that allow us to mount those fields, those keys, those values, those files, those certificates into the container naturally as part of the deployment process. So it's not burned into the image. It's something that actually gets mounted either into the process environment table or made available through files on the file system for the container. When we think about backing services, I can link to a network service. So I have a standard model now of saying, here is the way that my application exposes its network endpoints. This also relates to port binding. And I have a way of declaring I need to consume an existing service through this mechanism, right? So I get sort of a built-in poor man's load balancer for every application that I want to deploy. And this also makes sense for persistent volumes. If I want to attach the data that's actually driving my backing database, my data store, whether it's a cache or a relational database or NoSQL database, I can abstract the way that that storage is bound into the container, which means now, again, I can use that way of packaging a new version of the container, deploying it, and rebinding the same storage. That becomes very powerful if I want to do canary testing, where I'm constantly testing the new version of a database against my existing data and looking for problems on upgrade or regressions that have come into that code base. And then when we think about the process model, containers are exactly one-for-one the Linux kernel process model. When I stand up a container, I isolate that process from other processes in the operating system. I isolate its file system. I isolate its network namespace. And ultimately, it's still a simple process that is scheduled by the Linux kernel with this sort of little shell around it, the container itself. And so we think about pods as the way of structuring running a container or running a collection of containers as a unit. And we think about the notion of the container itself as just the simple process that's being run on a host. And where Kubernetes really brings a lot of power is when we think about how to orchestrate these containers. Right? Containers, to a large extent, have been around now for many years, but I think we're seeing the sort of transition point to more mainstream adoption, because what was lacking is not just simply how I build an application into a container or how I start a single instance of a container, but how I orchestrate a broader application problem, right? How I run things like 12-factor microservices. And so when we think about the different orchestration patterns that Kubernetes provides out of the box, we see deployment controllers and stateful sets applying a very specific opinion of how pods need to be operated. So how I scale them out, how I add additional pods, and this concept of disposability. What do I do when a pod fails? Well, the great thing is pods are largely unimportant, right? It's the collective use of all of the pods together that create an application. So if one pod fails because a node failed, because its storage went belly up or whatever, ultimately I have other instances of that application pod running. Each of those, again, are backed by or actually providing the backing to a service, which is then consumed by my applications or other consumers that are using that as an API or as a data store. So ultimately, each of the 12 factors maps very cleanly to these different aspects of Kubernetes. One of the neat ones that I find talking to folks that's kind of left out is, what do you do for admin processes? And Kubernetes jobs are a great way to do high-performance computing. I can do batch processing, maybe I process payroll, and it makes sense to do that in a batch as a job. But jobs also provide us a way that we can deliver admin tasks into a cluster in a way that it's very predictable. I can capture it as source code. I can manage it as part of a build. I can promote a migration job from one stage to the next. So jobs themselves become a powerful way to also administrate behavior on the cluster. And I think what we're seeing now is the evolution of things like operators, making that more of a first-class controller concept. And so we may see operators take over that role, but at least there's a way to do it today as well. So I'll show a simple application that meets 12-factor principles, and we'll see this in just a moment, but let's talk about sort of the structure. And then what I want to show you is also how we can use Kubernetes even for apps that weren't built with strict 12-factor principles in mind, how the support in Kubernetes that maps to 12-factor can carry over and make it easier to manage more standalone or traditional applications or workloads. And we'll see some examples with Helm of that, using Helm to do that in just a moment. But just a simple example. So this is just a node application. It happens to talk to one of our services in IBM Cloud. But this is true for any application, any 12-factor app that you'd want to build. Generally, you're going to have the app itself. And that typically, for a stateless service, you're going to use a Kubernetes deployment in order to describe that pod and describe how to scale it out, how many desired replicas do I want. A key factor here is that these instances are typically stateless, because remember, one of the principles of 12-factor is I use backing services and port bindings to isolate other dependencies. So if I need a cache, then all of the pods are going to connect to a shared cache. That cache might itself be running as a collection of pods, right? So each layer of the dependency tree is using all of the same principles. I can expose this application through a service. So the Kubernetes service basically acts like a local load balancer. It can reference or be exposed outside of the cluster as a load balancer service. It can be used locally, where it simply provides a local facade to many pods that are behind it. And you can even use a trick with Kubernetes services today where you declare it as an external name. And now it becomes kind of a way to have a unique alias that says, well, this actual dependency is an external service that's off cluster, but I still want to explicitly declare it. So when I do source control and I look at my pod depends on API A, B, and C, even if those APIs aren't running as pods in the same cluster, I want to see them listed out so I can actually manage them more effectively. And so if you want to take a look at a realistic example, so this is actually on GitHub. So if you look up my repo on GitHub, you can find this app. But just to kind of show a simple 12-factor microservice, Again, as a deployment, I'm describing things like the number of replicas, because each of these replicas, each of these pods is stateless. So if one fails, i.e. is disposable, then the deployment controller will simply create new replicas to take over that role. In this case, the pod does not actually interact with any storage, so it's truly stateless, but it does actually consume an upstream service, an API, from in this case, from IBM Cloud, but it could be any environment. And so in this case, we're actually seeing a workspace ID, which is the config map.
The keynote doors are now open. Please make it
Excellent.
to Hall 6 across the hallways at 4:45 start.
Thank you for this pause for the public safety announcement. All right. And then also it actually binds in a secret into this model as well. The config map and secret aren't shown in this file because you would create them for your specific application. But like we saw on the slide, the config map ultimately loads this workspace ID as a variable in the process table of this container. And this is that principle of separating the configuration from the application from the source code. So, so that's fairly simple to take a stateless app, deploy it in Kubernetes, map it to those 12-factor principles. If we kind of take a closer look here, we're looking at each of these different each of these different characteristics. So, and I'm not going to turn around because that's actually a little bit dizzying just to see it at that angle. That's weird. Anyway, so container images themselves, we're capturing that as Docker files. Docker files are easy to source control. The configuration, the example we looked at here is a deployment. That's also easy to source control. And because they're easy to source control, they're easy to incorporate into a continuous delivery pipeline. And this ultimately is what drives the culture change that you need in order to be competitive. It's not that containers or Kubernetes are magic and help enable new entrepreneurial business models or help enable disruptive business models. It's that they provide some of the characteristics and the tools that your culture needs to use in order to be more adaptive to your environment. When we look at the deploy factors, again, config maps, secrets are a way to expose that information into the pod. And ultimately, the pods themselves are these disposable instances which are managed as processes in the application. So this is kind of just a visual picture of what we've been talking about. The pod itself contains multiple containers. Those containers may or may not bind to additional storage volumes. And then those pods might then expose one or more services. And then for operate, we look at the notion of the different controllers. So deployment is one controller that supports a stateless workload. We also see controllers around things like stateful workloads. These ultimately are typically used for databases, where the way that I replace a pod is important. So if I think about something like etcd, it has maybe 3 replicas. They establish a notion of quorum. If one replica is lost, I actually want the new pod to have the same name and to begin to look like the replica that was lost. So they're slightly less disposable. I can recover if they fail. But if I'm dealing with a stateless application, I can add 10 instances all at the same time. If I'm dealing with a stateful workload, I may want to have replica 1 come online first, then replica 2 come online, sync with its prior replica, replica 3 come online. And that's really what a stateful workload controller does compared to a deployment workload controller. Okay, so how many of you have 100% of your applications today that you run that are not running in containers, that are already running in 12 factors, already running as microservices? How many of you have pure microservice architectures from beginning to end today? All right, so we got one guy in a startup probably, maybe a successful one, but largely this is not the case. Most enterprises that we talk to have a large amount of IT that's not fully containerized, hasn't been built with these principles, because state-of-the-art 10 years ago was different. State-of-the-art 10 years ago was I build Java runtimes, Java applications, I cluster those applications, I roll out updates to the schema, updates to the application, updates to my load balancer layer all together, and I do very specific blue-green zones that are mirrors. And if one zone is lost, I can fall back to the other one. I can take one zone offline during a low period, upgrade it, bring it back online. The challenge with that style of architecture is that it just requires more human coordination, right? Because I'm actually coordinating all of the humans making changes to these different layers. When I go to containers and Kubernetes, more of that intelligence is baked into the platform itself. Okay, so how does this help me if I'm running an application that's different? Well, it turns out that characteristics that may have been put into Kubernetes to support 12-factor also make it easier to manage these traditional workloads. So for example, Helm charts are a way that not only allow us to represent microservices and 12-factor apps, but I can take an existing standalone application, build it into a container, and then describe how to provide its configuration through config maps and secrets. Can describe how to bind its available services through a Kubernetes service definition. Can describe how to differentiate the process from the storage using a Kubernetes persistent volume claim and persistent volume. And now, even though this large container is bigger than a traditional microservice, and even though it may not meet all the principles of stateless services and it may not be as disposable, it still enables me to do better continuous delivery. I can begin applying things like canary testing. I can begin replicating development environments that match more closely to the same versions of messaging services, database services, caches, et cetera, that are used in production. And so in this case, I'll pick on an example, which is IBM MQ series. MQ has been around. There may be some of you in the room that are younger than MQ. It's been around for a while. And it's a core part of messaging layers for lots of financial services and insurance in many industries. I'm not here to tell you about how great MQ is, but it's a great example of an app that's not 12-factor, predates a lot of this current knowledge and point of view, but ultimately is still valuable to capture as a container and run using these principles. So what we're going to look at is a Helm chart for MQ, where we'll see how secrets are used to manage things like its certificates or the credentials to run. We'll see how MQ itself is running as a container image and ultimately takes advantage of this process model provided by the container and the orchestration model provided around it by Kubernetes. And then ultimately this enables us to make a full version of this messaging service and plug in your favorite traditional middleware or backend service that you need to say instead of MQ, but it allows me to then plug that into how my 12-factor services are doing their job. Because 12-factor services are only interesting if they have data more often than not, if they have messaging, if they have caching, right? 12-factor services with zero data, zero attachment to real information in the real world are, I'd love to see if you have interesting examples, but I typically find they're always attached to these other things that don't fit neatly in the 12-factor box. We'll look at the operator factors here, and I say operator, I mean operate. In this example, we'll talk about a stateful set. So it'll actually have MQ running as a stateful set, running as pods that can mount persistent volumes. And ultimately, these pods are now generating logs and metrics and other visibility, other notions of observability that you need to satisfy. When you build out a Kubernetes platform, you're beginning to adopt this as your principal way of delivering your applications. Those aspects of how I begin to manage those workloads, manage those pods, that's a problem you need to focus on, because that's probably the next big layer of problem we have to solve today. So when we think about continuous delivery now, even though these workloads that don't fit traditional 12-factor even though they don't fit into that mold, because we're using principles like containerization, like source control to manage those services, those declarations of configuration, they become easier now to integrate into your continuous delivery pipeline and allow you to begin leveraging a platform like Kubernetes to improve your entire ecosystem, not just that percentage of microservices that make up sort of the tip of the iceberg. That's maybe the big punchline I want you to walk away with today. So in this example, what I'll do is I'll start with just a set of Helm charts, and you can browse these on GitHub if you'd like. They're at github.com. And what I'm using are the ones that IBM has been building in the community. So these represent open source middleware and IBM middleware. And what I want you to take away is not necessarily that you should go and adopt this as your only path, but they do represent a lot of good learning and examples that we've absorbed and begun sharing in the community. And so if you look here, what you'll find is that there's actually many Helm charts available. And so we're going to pick on the one for MQ. And so if you're trying to understand how these principles really get applied to this style, I can drill into the Helm chart. And what I'm looking at now are a collection of template files Each template file then maps to one of these concepts that we've been talking about. Okay, and this is true for all of the workloads that are out here. And I can actually go and deploy this in my environment. So let's take a look at that now. So here I've got a cluster. And I'm going to change my export here. All right. So I've got Helm installed, and I can list all of these Helm releases. And it doesn't display as neatly as I'd like it to on the screen. But what you can see is that I've got certain charts that are deployed. This is the MQ chart. I can see the version that's running. And I can actually now deploy this workload very easily using Helm. So what it's going to do is it's going to take a version of this template that you can review on GitHub and stand up a live running instance. Then we're going to take a look at that. So in order to bring all of these parts together, Helm has been part of that CI/CD process to package all of the files. It's referencing a built image for my container. And then it's going to deploy all of those different parts and create the full application. And so this command is saying Helm install, giving it a name. And I'm actually going to modify the name here. It's giving it a particular chart that I want to deploy. So I have an entire repository of available charts. And then it's setting some variables, how I want that actual chart configured. And now that it's deployed, I'm going to switch into a UI just to show you it because I think it's easier to review in this way. But the version that I just deployed is now standing up all of these different piece parts from Kubernetes to enable us to take advantage of a 12-factor app. And so in this view, all I'm really trying to highlight are what are all the different parts that come together, right? So 12-factor says you need disposable processes, you need pods, as an example in Kubernetes. So it's running that pod that's now coming online. I need configuration for how I want to specify credentials for the application. So I have a secret that's mounted into the pod. I need to expose not only a network service for the admin console or for applications, but also a service for my Prometheus metrics. So I've got two services that are defined in this example. I could disable one or more services if I chose, right, through the options. And ultimately, it's running that stateful set, right, that controller which brings this particular pod online in a particular way because this is a stateful workload. So the punchline here is simply that Kubernetes by itself has already done a lot to bring the principles that 12-factor highlights into the way that you create applications. And these principles apply to your 12-factor microservices and to other workloads that you already have available as well. One thing that I'll leave you with just here, if you're interested to learn more, we actually have a free book that you can take a picture of the QR code, download. It's just walking you through how to do each of these different things, how to use Helm charts as a way to run middleware, how you need to address the operational control plane around that, how you need to manage security services or use horizontal or vertical pods, auto-scaling policies. And it breaks down from the very basic concepts all the way through to what you need to do in the enterprise. And for folks that have been taking pictures throughout the talk, if you want to copy the slides, you can actually just take a picture of the QR code and download a copy as well. So with that, and in fact, also in the book, we'll be doing a book signing at the booth tomorrow, the IBM booth, I think at 2:30.
2:30.
So you can come get a real hard copy and take it home if you want to do that, or grab a digital copy. And I think we're right at time, so maybe we'll take questions up here after if there's any comments or questions. Can I do one quick thing? Do you guys mind if I take a quick selfie of the room? Is that okay? If you... Get in there. All right, can you get in? All right, 1, 2, Kubernetes. All right, thanks. Have a good one.